Today I wanted to talk to you guys about something. I wanted to talk about a toolbox. And the toolbox is really all the different tools and techniques you know. It's everything you've learned in your career. And you really, whenever you see a problem, you can only get the tools that you have in your toolbox to tackle that problem. So it's in our best benefit to keep expanding our toolbox, because if you only have a hammer, certain problems are just not hammer problems. And the same goes with databases, with programming languages. Some programming languages, some databases are just more fit for certain problems than others. So learning more and more about these different techniques is important to keep it up to date. And actually things that you think now are just a hype and will probably go away, but some of those hypes actually become a standard. And I want to just quickly take you back through time. So we're going backwards. And just see how creepy it quickly gets when we see which things didn't exist yet. So the first one is actually a half a year ago. The new Java LTS came out. That's only half a year ago. So that's not that creepy. We could probably, I think most of you remember a time before Java 17 was available. Let's go back. I don't know if there are any Quarkus developers here, but Quarkus officially launched 2019. And Quarkus is a new framework that's been getting quite a bit of traction. And that's only 3 years old by now. So that's not that old. Kotlin, I noticed that Silicon Brighton has also the Kotlin user group. So Kotlin is only, and I need to count now, 6 years old. So if you go back 6 years ago, I was already in my career when this thing came out, and now it's become the default programming language for Android. It's become a very big programming language for backend software as well. So it's a bit creepy how quickly these things can go from something completely new to something that's industry standard. No, Kotlin they've been talking a lot about Kotlin before it actually came out. I had a meetup with Hadi Hariri, the main guy from JetBrains, 8 years ago, and he was already talking about Kotlin. But if I'm correct, the 15th of February 2016 was the 1.0 release. It gets even creepier. Kubernetes, I don't know how you pronounce it in the UK. I call it Kubernetes K8, whatever you want to call it. But it's a very popular platform to deploy your applications on. And that's only 1 year older. So that's not even that old. And a lot of software now runs on this platform. So if you thought back then, oh, I'm not going to learn it because it's just a hype. It's pretty standard right now. And now we get into the creepy ones. Spring Boot, probably the most popular framework, is only 8 years old. So I unfortunately remember a time before Spring Boot when software development in Java was quite a pain with things like WebSphere. So just goes to show how much you need to keep your knowledge up to date. And probably the creepiest one, it's Docker. So Docker is only 9 years old by now. So 9 years ago, it almost feels like we have to go back to the Stone Age. But what I wanted to show you with this list is that, you need to keep on growing, because I've been in the industry for 8-9 years, so around the time Docker came out. So if I thought that, I leave school and I'm done now, then I would have been, in big trouble right now, because all projects that I know use these kind of tools, at least Docker, Spring Boot. So we need to keep learning. But there's a problem, and the problem goes back to Halflife. So Halflife is a video game. That's actually not what it's about. But a Halflife is a term that is the time that's required for something, so a quantity, to reduce to half its initial value. It's usually used in when there's nuclear fallout or whatever. Maybe not the best topic for these times, but we're going with it anyway. So it's the time required for any quantity to reduce to half its initial value. And unfortunately for us, there's also a half-life of relevant knowledge. So how long do you think it takes before half of your knowledge becomes useless? And that's a genuine question. So if anyone can type something in chat so I don't feel lonely. So how many years does it take before half of your knowledge becomes pretty much irrelevant? Good time for me to get a sip.
Do you mean how old you have to be, Tom? Or how?
No. How long does it take? What's the half-life? So a half-life is the time it takes for something to reduce to half its initial value. So what I mean with this question is, how long does it take before half of the things you know in the IT sector become irrelevant?
Okay.
Roland, Chris?
So we're starting to think about, I guess, the acceleration of digital transformation.
For example.
Possibly.
So, yeah. Well, actually, it's somewhere between 2 and 5 years. So that's really creepy because I don't know how long the formal education is IT-wise in the UK. In Belgium, it's 3 years. So that means that probably about half of your knowledge has already evaporated by the time that you leave university. So that's very creepy. So that actually shows that we need a good strategy to keep up to date with our knowledge and to keep learning. So that's what I wanted to talk to you guys and girls about tonight. We're going through a few different phases. I'm just going to go one by one. And the first thing is, well, let's look at the things we want to learn and what are the right things to learn about. And that's kind of a creepy terminology, like what's the right thing? You need to learn this, not that. Sounds a bit creepy. I'm going to explain it to you in a bit. Because how do you normally learn? Well, I usually learn through books, but if you look at all the new knowledge in the IT sector, this is sometimes what it feels like. Standing in front of a big book closet with a lot of books, it's like, oh my God, where am I even supposed to begin? So that's very daunting. You can even, in a modern era, replace these books with like different websites, tutorials, plural site, whatever. There's a lot of information coming your way. So how do you choose? Well, it actually goes back to a pretty simple theory called the zone of proximal development. So let's have a short look at that one. So these are 3 circles with like a bullseye. And right in the middle is everything you know. So that's all the knowledge you've gotten, all the experience. So that's within the inner circle. One a little bit outside of what you know are the things you can learn. So you can quite comfortably learn new knowledge that's in this extra circle. And you have the outside circle, which are things that you're not capable of learning yet. And that usually needs some examples. So I'm going to do a pretty simple example with HTML and CSS. So if you know HTML styling, so you know how to style an element using the style attribute, then you already know quite a bit of CSS. So the jump from HTML styling to CSS is a reasonable one to learn. But if you only know HTML styling, then making complex CSS animations is maybe a bit too far for you. So that's what the circle actually means. It's really investigating what knowledge do I have right now? Which things am I comfortable learning? So that's like one step outside of your comfort zone. And then you have things that are just too difficult for you to learn at the moment. Doesn't mean you can't ever do it. It just means that you need steps in between to get to that phase. Because whenever you learn something, your circle expands and then there's new things that are within your reach. And actually why that works is something called cognitive load. So I don't know if some of you know cognitive load theory, but cognitive load theory, if I corrupt the terminology a bit, it basically means that we're all computers and that as our internal memory works, we can only remember 6 to 7 things at once or load 6 to 7 things in our working memory. So that's not a lot. And that puts a lot of load on our brain. So there's different kinds of load that can fill up in the working memory. One of them is intrinsic load. Some tasks are just more difficult than others. If I ask you to calculate what's 2 times 2, you don't even have to think about it. It's click and you have the answer. But when I ask you to prove the relativity theory, that's quite complex, just intrinsically. Then there's extraneous load. And extraneous load is something really weird that almost nobody really takes into account. But one good example is if you go to a tutorial website and there's like blinking commercials next to it, like ads, those are extraneous load. They have nothing to do with the thing you're trying to learn, but they're just in the way. This extraneous load part also happens when you have a slide with a lot of animations, or a teacher that's constantly like walking back and forth and actually not paying attention to you. That's just extra loads that you are compacting in your head. So you only have 7 of these slots, or 8, or 6, 7, 8, around that. So you can only hold that much in your memory. But there's a twist, because an entire programming language you can keep in your head somehow, because you know how to program Java. So that's more than 7 things. So how does that work? Well, actually, whenever you learn something and you put it in your long-term memory, when you really study something, that forms a schema or a schemata. And those things only take up one piece of your memory. So your working memory is limited, only 7 things at a time, but your long-term memory has no known limits, and it clusters information together in a neat package. And those neat packages only take up 1 slot of those 7 or 8 slots. So that's pretty cool. So for example, one schemata could be how to do SQL. It has many little parts, but you can actually load it into your working memory without much trouble. So it's a bit of theory, but it actually explains why the first circle makes sense, because you can't actually learn new things because it's so new that it takes up all your working memory. And it actually says something about, then what should we be learning? The initial question I posed, well, we should be learning things that are very useful in the long term, things that are really good to have in your long-term memory. And the more of those things you have in your long-term memory, the more efficient you can be as a coder, and how more efficient you can learn new things as well. There's 2 concepts that are very important here. The first one is technical implementations fade faster than the concepts they're based on. So what does it actually mean? Concepts don't go away that fast. So if you manage to get a concept like object-oriented programming, test-driven development, reactive programming into your head, you can easily extrapolate that when you go to a new programming language. Because if you learn Java and then you do C#, a lot of the concepts are already the same. Same with test-driven development. In most cases, it's pretty much the same, as a bit of different tooling. So if you're looking into what do I want to learn, unfortunately, it's not the most sexy thing to learn, but those fundamentals, those concepts really are portable. And these don't decay as fast. I talked about the half-life of knowledge, but that's an average. There's things that don't decay as fast and that you can have a benefit from for years to come. Design patterns is another cool one, because if you know a few design patterns and you're able to recognize them, you're often able to recognize them in multiple programming languages or new frameworks. So if you're going to study something, think about those concepts. So 2 things to keep into account. Beware of your cognitive load. So don't try to put too much into your brain at the same time. So try to find things that are just outside your comfort zone and not too far, so you can actually study more efficiently. And remember, I see so many junior developers saying, oh, I want to learn framework X, framework Y, framework Z. But actually, those frameworks are almost always the same. They just have the same concept. So if you focus on the concepts, then in the longer term, you're able to absorb new frameworks as well. If you are struggling with finding those next steps, because I'm saying it here like it's pretty easy to find what's the next circle, like what's the convenient step for you to go next, there's help. you can contact people at this JUG, for example, to reach out for help. One thing that I do as a coach is I'm a coach on codingcoach.io, which is a free free coaching platform where they actually match developers who have a bit of time, like me, and developers who are looking for someone to help them like figure out what the good next step is. And yeah, just remember that when you don't have the tools and when you don't keep expanding your knowledge, you often like approach a problem with a wrong tool, and you need to actually work a bit with the knowledge you have to really feel all the details and the nuances of a new framework as well. So that was the first thing. So finding the right things to learn about is basically focus on the concepts and make sure that you try to not push yourself too much, but learn things that are within your comfort zone and then keep expanding on that. So the second thing I find very important is to apply what you've learned. Because if you've learned a lot from a book and you never use it, then it doesn't stick into your long-term memory as well as it would when you've just read. More theory. So I'm going to go through this one very fast. So this is, I didn't mention this during the intro, I actually have a teacher's degree, and this is something that they teach you in the teacher, how do you say it? So this is something they teach you in the teaching degree. So when you're learning to become a teacher, this is like the go-to diagram of things you need to do. And it basically shows you how to build up your lesson plan. So at first, you need to help the students to remember some information. It's really difficult to talk about Paris if you have no idea what Paris is. You need to have at least some concept that it's a city in France, and you need to be able to remember a few things. But you need this base, it's really a reverse pyramid. So you really need that basis of remembering simple things like what's a class, what's a variable, to be able to understand the information. And now if you look at let me just skip the applying one for now. If you look at the top 3 ones, so creating, evaluating, and analyzing, that's actually what we're being paid for as software developers. So as a software developer, we're often paid to create something new, to create a new piece of software. We're hired to evaluate some tools and make judgments. Are we going to build this piece of software ourselves, or are we going to buy a product that's available online? And we need to analyze. We need to analyze a lot of information from business owners from all over the place. So, but in order to do these 3 things, you need to be able to apply the knowledge that you've learned before. So applying is really, and applying what you've learned is really a central piece in this diagram. By the way, if there's any questions, just drop it in chat and I'll see what's going on. So this is called Bloom's taxonomy. I've always have resources, and the slides will be available after the talk. So yeah, the talk is called Learning Through Tinkering. So when I had the first iterations of this talk, I didn't have a definition of tinkering. So let's go through that one first. So what is tinkering? It's experimenting with ideas and frameworks in an integrated environment to fully understand their capabilities. So that means that if you learn about a new programming language, well, then use the actual programming languages with some of the complexity around it. Find first a simple way to do it, but try to apply as much of the things that you learn. Don't just read about it. So when I talk about people like, hey, you need to apply what you've learned, you've read about this cool stuff, now what are you going to do with it? A lot of my colleagues say, yeah, I read some cool stuff, I have no idea how to apply it. So in this piece, this part of the talk, I'm going through a few examples of how I approach my studies and learning new technologies and some of the things you need to watch out for. So that's what I'm going to do now. So the first thing you need to do is really limit yourself. And the limiting yourself really goes back to the circles I showed you. Try not to learn too many things at once, because the more you try to learn at once, the less will actually be able to be saved in your long-term memory, because you're just so full with new information that it doesn't store anything to the long-term memory anymore. And that's kind of a shame. So the way I did this, I don't know if anyone recognizes this picture while I take a sip. Eerie silence. Maybe it's just me, maybe I've just gotten old, but this is a fan picture of a video game called Portal. In Portal, you have a portal gun where you have to shoot and different things, but the cutest part is the cube. There's this cube that it's almost like a pet or a friend that you have to carry everywhere. And Portal is a really physical game, so you drop things, you can throw things, and I kind of wanted to make it myself. And the way I did this was I wanted to learn a bit more about object-oriented programming in Java. So I tried to build it with only using Java. So the topic of this chapter was limit yourself. So the way I limited myself was I'm going to make a video game, but I'm only going to use Java. So let's have a look. It's time for the first code example. So you actually need two things if you're going to make a video game. The first thing you need is you need a game framework, which you can either just use online or build yourself. And I found a website online, I'll drop the link later, that actually explains how you can build your own gaming framework. And it explained it in such a way that it actually uses clean, simple interfaces and then different implementations based on what kind of platform you're using. So these are interfaces. You can implement them in Android, you can implement them in something else. But for me, I decided to implement them using JavaFX. So when I ran into this, I was really surprised how clean the design was. It's all interfaces, so you don't know much about the implementation. And one of the core tenets of clean design is always talk to an implementation, I said that wrongly. Always talk to an interface, never to an implementation. So this is like a textbook example of how you can do such a structure. So I found that online. I'll drop the link, no worries. The second thing you need is to build physics. And physics are a bit tricky. It's a lot of math. I don't like math. But luckily for me, I was able to find, and I'll just share this one. It's the nature of code. And this guy has made an online book that's online for free that explains everything you need to know about physics. And he explains it using beautiful code. So this is like a simple example of what that might look like. So having this knowledge, I decided, and using these examples, I decided to build something like this in Java. So what does that look like? I have my game here. Let me just start it, and it's going to start full screen probably and mess up my stream a little bit. Compiling. There we go. Oop. So it's very simple start. So you can really see the gravity pulling. So it's accelerating a bit as it hits the bottom, and once it hits the bottom, it just stops. So what does that code look like? Well, the way he explained it, everything is basically vector-based. So let me just first have a look here. So any item in the game is a 2D vector. You have a location, that's the exact position where something is at the moment. A velocity, that's how fast something's going. So I'm going to try to do this while walking around. So this is a pretty steady velocity while I'm walking around in my room. It's pretty steady. And then you have an acceleration. So that's how much your velocity is increasing or decreasing. And then once you do that, everything you need to do is an update. Because every tick, so every second, millisecond, whatever you want to do, your velocity gets added, your acceleration gets added to your velocity. So that's how much your speed is changing. Your location is changing by your velocity, of course. And then, you need to set acceleration to 0 or it will exponentially keep growing. So that's how all the objects in the game work. So in the logic part, so you saw before the cube just falling down. So before you saw the cube just falling down. Maybe if I do some hand movement, that's a bit clearer. And I have a couple of things I can do. If I press space, the cube will actually reset to the top of the screen. And then I have something called a CC, that's the cube, a companion cube. That's for all the hearts, it's a companion. And when it collides with the floor, you can either set the velocity to 0 because it stops, it's an abrupt stop, or else you apply a force. And actually everything in the world is just applying a force. So for example, gravity is constantly pulling me down, all of you as well, because else you would be floating. When I throw something, that's a force. Wind could be a force. So using this programming model, it's actually really easy to build like a pretty complex game just by using physics and applying forces. So just as a quick example, you could program this out with X and Y and manipulating the objects themselves directly, but using this approach, it leaves your code pretty clean. So if we want to add a force, I can just add a new force, let's call it wind. And the force has an X and a Y. Well, gravity is Y because it will pull you down, but wind, let's just say that wind will pull us sideways. And then if I want to apply this thing, I'll do it together with gravity. I say CC dot apply force wind. And now if I run this example again, and I hope I did it correctly. Oh, that's maybe a bit too much wind. So that's that works. Now the cool thing is, if you want to reduce the wind, it's all in one place. You go here to your vector, you decrease it a bit. Let's say 0.5. You run it again. And there we go. It's less wind, so it takes a bit longer before it hits the side. So what was the point of showing you all this? Well, I decided to limit myself by only doing Java. And because I was only doing Java, I was able to learn a lot of different things I needed for game development. In the past, I've often made the mistake like, oh yeah, I'm going to do game development. Oh, I need C# for that with Unity or whatever. And it's just too much things to learn. So actually by limiting myself to, I just want to do Java. I don't want to use any frameworks. I'm going to build everything myself here. I learned a lot more about Java and about physics, things that I wouldn't be able to internalize if I tried to learn more different things at once. So the first thing is, if you're going to do something, try to limit yourself and see how much you can learn. The second thing you should probably do is whenever you build something, reflect on what you've done and what you've learned. And this lesson comes pretty hard for me because I had the privilege to teach students 4 months of Java. So that's me in a classroom with 11 students and only Java topics, going from a simple hello world to building complex microservices. But there was one thing I really hated doing every morning, and that's getting an attendance list. So I had to like look at my class, see if everyone's there and mark them. So I was like, oh, I can automate this. So I'm going to take a camera, I'm going to point it at the door, and then I'm going to use some machine learning to detect which people actually walked in. This was before GDPR or any regulation that would have said that I couldn't do this. So I just did it. But there was one little problem. I have a camera, which is video that's multiple, that constant stream of pictures, basically. And this API only accepted single images. So I had to put some kind of software in between, and that is something called OpenCV. So OpenCV is a piece of software that can do a lot of video manipulation. I can't actually show you the demo because there's something wonky going on with my, my camera, but I will share you the code. So what that actually does is it takes the stream from your camera and it has something that's really cool. It ships with facial recognition. So I can quickly show you the code though. So here I select the camera. I load something to detect the front of a face. This is packaged with the OpenCV when you download it, so you don't have to train anything. The machine learning just works. And then some codes to actually read some frames. It's actually not that exciting. And it worked. I applied it. I showed it to my students. Everyone was excited because they're all technology nerds, so they kind of enjoyed the idea. But then I had one student come up to me like, "Oh, Tom, I was in your class every day, but it's not registering me. It's not saying that I was here." And I thought, you know what? That's awesome. So not that you're not registering, that's awful, but let's look together. It's going to be a teaching moment. It's going to be a learning experience. Let's look together why it isn't working. So we were trying and trying, and it wasn't working for this specific person. And then I thought, you know what, let's forget about the camera. Let's just see what the algorithm, so the machine learning, does if we supply it a picture. And this was the picture I gave it. And yeah, let's just say it didn't end well. So I didn't know, but for some reason, the pre-packaged machine learning thing that was packaged with OpenCV, which is a very famous library for doing these things, has a little problem. It's awfully racist. And this is not good because you can already guess like the ethnicity of my student. So what does this mean for me? Now, what does it mean for my student? Well, I felt like shit. That's hopefully the only swear word I'm going to say, but I think it's appropriate. Because I do not like being non-inclusive. I hate it. But somehow it happened. I was so excited about the cool technology, the cool thing that I built, that I actually forgot to check, is this actually inclusive? Does this work correctly? So what I just want to say with this is, if you build something, even if it's for fun, reflect and see what kind of lessons can I learn from this, and take it to your professional life. So can you imagine the look on my face when my project manager asked me, "Hey, Tom, do you want to do a machine learning project?" My face was, hell no. I'm not going. I know where this can go. I know what this can lead to. So let's just not do that. So you can learn a lot, but really take a moment whenever you've built something to reflect back on, is this really what I wanted to learn? Is this really good? What kind of lessons can I take to my professional life? The next one is also pretty important, because I told you about the circles, and the next step of the next things you can learn, you need to be really conscious about it. You need to really think about what your learning goals are. Does anyone know what this is, by the way? While I get a sip. By the way, there's not many people, so if you're comfortable, you can always just unmute and yell at me. That's also fine. Nobody? So this is the Large Hadron Collider. So that's that big circle thing they built to discover more about the universe. And what they did was, so basically how it works is they accelerate two particles, so two atoms or particle, they accelerate them really quickly, and then they smash them together. And the idea is that you can learn more about the universe by breaking it apart, and hopefully not creating a black hole and destroying everyone. That's besides the point. That would be an unfortunate side effect. So we can do something like this in our professional lives as well. And that's called a bit of reverse engineering. We try to look at things and see how do they work, and we try to build them ourselves. So that's a fun thing to do. So this was a couple of years ago, and I decided I wanted to make Pokemon Go. I know it's getting a bit older now, so it's a bit weird to still talk about it, but I didn't want to build a new app. I wanted to build the backend where the Java is, because, by the way, Pokemon Go was designed in Java. So big hooray for us. So what I found this amazing Reddit site where they actually describe how this works in detail by people that are way smarter than me, but I learned a lot just by reading it and then trying to apply those things as well. So I learned about, protocol buffers. It's not JSON. They use protocol buffers. It doesn't even matter. It's way faster, apparently. Cool. I learned about a new thing called S2 geometry, which is a different, you know, the normal GPS coordinates with latitude, longitude. This is a totally different way to work with it, to work with geometry. And that's cool. But yeah, I totally went off the rails. I spent hours and hours looking at how it worked, and I hardly applied anything. I hardly touched my keyboard to type code myself. I was just learning and learning and learning, and honestly, I've forgotten most of it. So my initial learning goal was, I want to learn more about how this works, and I want to build it myself, and then I didn't build it myself. So I had the same thing happen to me recently again. I don't know if you know Wordle, the very popular word game. So Wordle, I decided to automate it so that I had a bot that just fills it in for me. And the real learning goal I had there was I want to learn to automate websites. What ended up happening was me figuring out what the best word is and going into dictionaries and trying to figure all that stuff out. Well, that wasn't really my learning goal. My learning goal was automating websites. So it's really dangerous to get caught in this trap with learning 10,000 different things. But yeah, you need to be really conscious about what am I actually trying to learn here. And the last thing I wanted to show you demo-wise is, yeah, try something alternative. So I talked about machine learning before. That went horribly wrong. So I decided I was going to make a new game and try again, but then personally. So I decided to make, like, I don't know if any of you remember Flappy Bird still, where you tap your screen and the bird flies a little bit. Well, I decided that I wanted to make that, but with this little character. And bonus points to whoever knows what this character is, by the way, while I start up the demo. Nobody? Nobody know what the character is? He's here again. You see, when I click it, I actually reused quite a bit of the knowledge I got from the previous game as well. So there we go. See, and he flies. But I thought, you know what? That's not fun enough. And then I was looking around my room, and then it's time to introduce my co-host. Hi. So I decided, wouldn't it be cool for my nephews, not for me, if I could control that game using this plush animal? So I decided to look around, and you know, you need to train a pretty complex machine learning algorithm for that. Or there's this new thing called the teachable machine, where you can quickly learn that, well, do some machine learning. And that's what I'm going to try right now. I'm going to disable a couple of things because my camera is actually pretty wonky when it comes to this website. I should be right back. There, see, there I am. Hello. So what are we going to do? So we're going to train a machine learning algorithm that uses a neural network. So to make the bird, it's a Totoro, by the way, from Studio Ghibli. So you see, if I click it, it flies. Well, the way I'm going to make it fly is I'm going to train a machine learning algorithm to detect two things. I'm going to detect open arms like this, and then I'm going to detect closed arms like this. And the idea is, if I want to make a jump movement, then he has to flap. So it's a transition from open to closed. So let's start training this algorithm. So I need two different example sets. So these are the two things that I want to recognize in the end. And now I just need to provide it with a bunch of examples, and then the machine learning algorithm can train itself, and then we can use it. So let me just, this is open. Let me just okay. Open arms. Nice. Closer, distance. Oh. All right. So now we have a bunch of examples with arms open from different sides. And now I need to do the same with arms closed, and I just need to duck out of the way. There. There we go, arms closed. All right, now all that's left is to click train model. And the cool thing is with this website, it doesn't take that long. It shouldn't take that long if my PC doesn't crash horribly. So normally training such an algorithm would take a couple of hours, but this website uses transfer learning, and it's actually already done. So hi everyone again. Let's see if it actually worked. So you can see the output below. So yeah, it's working fine. And here we go. Oop. Oop. Oh, I need to get out of the way, else it doesn't do it correctly. There we go. All right, I'm back. So what can we do now that we've trained this? We can export this model. You can actually upload it. And the cool thing is this actually shows you exactly the JavaScript code you need to run this example yourself. So that's pretty cool. So I get this machine learning model here. I've already prepared this in my own code. So that's here. Just need to replace this one. There we go. There we go. I just have a quick look if everything's okay here. That should be fine. And then close this one. Close this one. Just a second. This is not as smooth as I'd hoped, but the training is going well, so we'll see. All right, let me just open the developer mode. Oh, there it is. It's detecting open. Can I zoom in on this one? Yeah, okay, so you should be able to at least read it a little bit. So I'm going to get on release again. Oh. Just need to wait until it drops back down so I can actually show it. Oop. Oop. There we go. It's working. Somewhat. Come on. So it's not perfect, but it'll do for now. It'll do for now. So you can actually get it way better if you train some more. So what was the point of all this? Well, sometimes it's just cool to try alternative solutions to problems that you've already tackled. So if you're trying to build a new website and you want to learn a new programming language, then maybe try that new programming language, but make sure that you don't take on too many things at once. So what are the benefits of applying what you've learned? Well, I try to also fix my camera. Oh, it's stuck. Oh, that's a nice picture. It'll be fine. So what are the benefits? You improve your retention and recall. So you actually enforce that things go into your long-term memory, and you're able to more quickly retrieve them from your long-term memory as well. You can discover some unknown unknowns. So if you try a new framework and you run into issues, well, maybe that issue wasn't in the tutorial. So that's good that you run into it now, so you can learn why that issue is even a problem. And you can run into some quirks and hidden assumptions from the thing you're trying to learn now. Or find a simpler solution to solve X. I'm just quickly gonna change up my camera. This is really annoying. Oop. Oop. God, much better. So I'm going a bit over time. I hope that's not a problem for everyone. I think it will be like 5 to 10 minutes more. If you have issues, then please reach out to me, and then I'll cut it short. So what are some common mistakes? That's learning too much stuff. I've talked about this already. So really try to limit yourself in what you're trying to learn at the same time and hold back. I know it's tempting to start a project where you have a new kind of database, a new programming language, a new problem, but when you have too much new things, it actually pushes you into the outer circle. Too many things you want to do at once as well. What also doesn't work is cramming new knowledge. And I went to university. well, it's not university, it's university college. And I had a tendency to wait until the last evening, like maybe some of you did as well. And cramming it in the last night usually didn't work that well. And the same actually goes for learning new programming languages. Cramming it all in really quickly doesn't really transfer it to your long-term memory. So be really careful about that. Another common mistake is Stack Overflow-based development. A whole mouthful, but I think most developers will get what I mean. So that's the copy-paste loop. You have a problem, you find it on Stack Overflow, the solution, and you copy-paste it, and then you don't think about it anymore. That's actually really dangerous because, one, you don't know what you're copying if you don't take a moment to investigate, and two, you will not really remember the solution unless if you really take a moment to stop and try to understand what the solution actually means. So be careful with just going rogue and copy pasting things from Stack Overflow. So last part is how do you get the most out of your knowledge? So we've talked about finding the right things to learn about. We've talked about applying what you've learned. We've talked shortly about some common mistakes. So now how do you get the most out of your new knowledge? Most important one, share what you've learned. This can be a blog, this can be a talk, this can be even a simple tweet like, hey, I learned about something. But sharing what you learned actually enforces your learning quite a bit, because in order to give this talk, I had to investigate a couple of things. I had to go back to all those diagrams that I thought were useful. When you give a talk or you write a blog post about something like Quarkus or Spring Boot, you're actually forced to really understand it, because you can only they usually say you need to know about 10 times as much as about a topic than what you're actually saying during a talk, just to make sure that you get everything correct. So sharing what you've learned actually does two really big things. It helps you to study, but it also helps others to improve quite a bit. The second thing is do some good. This is like more a personal thing, but I'm of the idea that if you know things and sharing it, then use that knowledge to do some good. Like, for example, when COVID broke out, a lot of people were scrambling to get online with their grandparents who weren't capable of logging into Zoom. It was too complex. So I helped some people build a simple tool that just gives the link, and when they click the link, they're already in the call. No login, no username, nothing. And that's, I use my knowledge to do something good, and that really fills the soul. Same thing with the coding coach. I'm a coach on that platform as well, and being able to use my knowledge to help people in Ghana, all over the place was just warms my heart. I think the most important part is just be yourself. Have silly projects. Do whatever that gives you a bit of fun. Like I'm just a giant nerd who has like plush animals in the house, and I do silly stuff with them. But that's what I enjoy. So just don't be afraid to be yourself, and just take topics or take frameworks that you're really excited about. You don't have to force yourself to be anyone else. Just be yourself. So I started this talk by talking about your toolbox. Now you're constantly supposed to expand it and update it, because with this half-life of our knowledge, we're quickly losing a lot of knowledge that becomes less relevant. Because in the end, who's responsible to update and maintain your knowledge and skills? It's no longer a teacher who's going to help you. You are responsible for updating and maintaining your knowledge. You could say, oh yeah, but it's my manager, my company has to do it for me. But actually, if your company doesn't hint that you should be doing this, you should be going to them and talk and saying like, hey, I'm running behind on my knowledge. I need some help. Can I follow a training? Can I go to a meetup? Can I go to... And they should be able to help you out, because in the end, you're responsible. So I talked to you about this circle, and this is really the simplest and most effective piece of diagram that I've seen in my life. Because it is really about what you know, what you can learn, and what you can't learn. And I'll put it in more direct terms. If you do this wrong, and you stay in your circle of things you know, you will be bored. If you never do something new and exciting, you will be bored if you only stay within your inner circle. This is the sweet spot. 1 foot nice and cozy, where you learn new things, but also one foot in the place where you already have a lot of knowledge. And unfortunately, I say this one from experience, too much of the outer circle will lead you straight into a burnout, where you're constantly out of your comfort zone, learning new stuff. That's just dangerous. It takes a lot of energy. Be really careful and try to always be in this sweet spot where you're still learning, still being challenged, but are comfortable enough and relaxed enough to actually keep it going, because your career is not a sprint, it's a marathon, and it's a very long one. So these are the things we went through today. So if you're going to do one thing after this talk, then I'd say choose one topic, go tinker with it, go do something with something you're excited about. Just go and build something small, something silly, and share what you've learned. Just share it, write a blog, even if it's a tweet, just start sharing what you've learned. It's so much fun, and you help yourself and others with it. So I always end with this one. That's if you spend hours and hours watching meetups, tutorials, conferences, and you never apply what you've learned, then be careful, because maybe you're just wasting time. Apply what you've learned, actually share, and become a better developer.